Lesson 2 of Unit 6 addresses geodetics, which essentially discusses coordinate systems. In Exercise 1, you learn how to assign a coordinate system to a drawing. In Exercise 2, you assign a coordinate system to data. And then in Exercise 3, you can assemble data from multiple coordinate systems. Let's review coordinate systems first. Cartesian coordinate system is a simple rectangular coordinate system with commonly known as x and y values, and in this case quadrants. And a three-dimensional Cartesian coordinate system has a z value associated with the x and the y. A polar coordinate system is based on angles, and the primary example of a coordinate system is a latitude and longitude. And that is measuring the position on the surface of the Earth based on a position or an angle relative to the equator and also relative to the prime meridian. So the combination of latitude and longitude can give you your position based on polar coordinates on the surface of the Earth. Map projections are used to project a curved surface to a flat surface. So we're typically looking at maps on screens, on computer screens, or on hard pieces of paper. And you use a projection to project a curved surface to a flat screen or a flat surface. And the most common type of projection is a Mercator projection. And this is where you would project this to perhaps a cylindrical surface. And we'll look at that in a minute here, but the classic is the map of the world, and when you look at the distance or the size of Greenland, due to the projection, just the way the map is, it's physically appearing actually larger than South America, which indeed isn't the case. But the projection actually makes it appear that it is larger. It just happens that the distance of measurement and scale vary with the position on the map. Here's three examples of projection surfaces. You can have a cylindrical projection, in which case you're unrolling or the surface of the Earth onto a cylinder. You have a conical projection or also a planar projection. And the Mercator projection is a cylindrical projection. And a transverse Mercator projection is also a cylindrical projection. However, the location of the cylinder with respect to the position of the Earth varies. A conical projection is a similar type of projection, except it projects the Earth's surface onto a cone. And the Lambert conformal conic projection is perhaps the most common or the most familiar conical map projection used. Spheroids and ellipsoids are used to model the Earth's surface, and perhaps the most common is the WGS, World Geodetic System 84 ellipsoid, and they contain both horizontal and vertical datum information. So here you can see the surface of the Earth is actually an irregular shaped, the geoid for your vertical datum, and then the ellipsoid for your horizontal datum. Very important to understand in mapping is the difference between a ground level measurement and a grid level measurement. If you measure a distance on a ground, it is going to be different than that distance measured on the corresponding map projection. And that's where you would use a scale factor. You may have heard of the term scale factor to scale distances, and that's going to equate a ground level distance to a grid level distance, or a grid level distance to a ground level distance. In Exercise 1, you learn how to assign a coordinate system to a drawing. So let's go through that. We'll open the drawing for geospatial data in geodetics, Exercise 1. And a couple things here. In Civil 3D, there's an interface for assigning the coordinate system to a drawing, and then in map it's the same thing. There's a different interface element. So let's look at Civil 3D first. If I type in SHOWTS for show tool space. There's my tool space. If I go to the Settings tab and right click on the drawing name, I can edit drawing settings. And under the Units and Zone tab is where we can assign the projection. So perhaps we want to go down to USA Virginia and then choose a projection in Virginia. State plane, zone north meter, and then you can choose the projection this way. In Map 3D, if you click the Map Setup tab, you can assign a coordinate system using the Assign command here. And this will do the same thing, so I can now select a coordinate system here and assign a coordinate system to the drawing, USA Virginia, and choose the coordinate system this way. So a few ways of assigning coordinate systems, either through the tool space, which is going to be used with Civil 3D functions, or you can assign the coordinate system from the Map 3D workspace. You can also assign a coordinate system to data. So in the Data Connect window, you can right click on the data and edit the coordinate system. So for example, if we were to connect to some data here, we'll use the Data Connect, and let's add a shape connection here, call this parcels, and we'll go extract a parcels data file here, and we'll go into data, and we have some shape data here, and here's some parcels. Well, if we connect to that data, we'll be able to then assign a coordinate system. So if I edit the coordinate system for parcels, I can right click and select Edit Coordinate System. And you'll notice that the drawing is this particular coordinate system, but if I edit the coordinate system, I can assign a different coordinate system. And then when I add the data to the map, a coordinate transformation will occur. So that's nice to be able to perform coordinate transformations on data. And in the final exercise, you walk through some steps where you attach multiple data sources using multiple coordinate systems, and the data sources are transformed to the drawing coordinate system. And that concludes the discussion on geodetics in the geospatial unit.